Hi guys, Dr. Diaz here again, and today we're going to solve some of these problems. And if you can see, these problems are from the homework, and the way we solve this one is by using the definition that we have for summation, which is these two that are here. Now, in order to these equations work, I has to start from 1 all the way up to n. If you can see, none of these three examples we have here, they start at 1. So you have to change the integral summation. And how you do that? Well, I brought here an equation that more or less it will work. And yeah, I come up with this thing. So if you look at it in someone else and the equation is slightly different, okay. But I will show you how it works. So you change the integral summation. When you change the integral summation here, you have to change it here, and you have to change it also here. And I will show you how those problems work. And the main thing is that we want to turn this index into something like this from 1 to n, and then be able to use this formula. So let's do one of those problems. Let's start with this one. Oh, let me erase this thing. Let's start with this one. The one that it says summatory of I that it goes from 3 to 30 of I minus 3 squared plus I minus 3. The first thing we're going to do is we're going to change this index. So we're going to subtract here 2 to turn this I equal to 1. And if we subtract 2, we have to subtract here 2. But if we subtract 2 to here, we have to add here 2. And in this I, 2. So this thing is going to look like, this. I plus 2 minus 3 squared plus I plus 2 minus 3. Now if you simplify this and this, you will get I minus 1 squared, because 2 minus 3 is going to be negative 1, and I minus 1. It was the same thing. Now let's expand this I minus 1. So I minus 1 squared expanded is going to be, by using FOIL, I squared minus 2I plus 1. Now substituting this into this equation, we will get something like this, right? We get I squared minus 2I plus 1 plus this part here, I minus 1. And you can see that the 1 and 1 cancel. I squared stay alone. Minus 2I plus I is going to be minus I, and that will give us I squared minus I, summation. And now we can put these two into two different summations. Well, there you can see we took them into separate summations, right? And now using these rules or these two formulas, using these two formulas, we know we can find how much is I squared, and we can find how much is I. Now you can see the only thing we have to do is substitute here 28 plus 1, which is 29, and 2 times 28 plus 1, which is will be 56 plus 1, and all of that divided by 6, and we will have, then after substituting here also 28 and 28 plus 1, which is 29, we will get the first one is going to give us 7,714 minus this one is going to give us 406, and 7,714 minus 406 is 7,308. So we get the first problem done. Let's go to the next one. And we will end up with this. Now you can distribute the I here, and this is going to give us summation that it goes from 17 to I equal to 1 of I squared, let's put a parenthesis, I squared plus 6I. And now what we're going to do is we separate this summation and do it like summation 17 of I equal to 1 of I squared plus, and now we take 6 because it's a constant outside the summation, This is going to be 17, and it goes from I equal to 1 of I. And now with these two, we use the formulas we have a moment ago. Yeah, remember these two formulas? I just pick it up from up there. And now we're going to do the summation for I squared. We're using this one with 17, and for I with this one using n. And we will have something like this. And we will have this one that it says 17, putting 17 here. 17 plus 1 is 18. 2 times 17, which is 34, plus 1 is 35, and all then divided by 6. And this one, which is I, would be 17 times 17 plus 1, which is 18, divided by 2. We have it here. And this is going to give us, and after substituting the numbers, we get here 1,785 plus 918, and will give us 2,703. So that's the summation of this number after you do the change in the index. Now let's see the last problem here, which is a little bit more complicated. And the same as we did with the other two problems, we had to do the same thing. We had to change the index of summation in order to use this equation. The difference in this one is the upper limit here, or this number, is n. Yeah, it's n, it's not a number. So okay, it doesn't matter. This is how we proceed. What we do is we subtract 2 here. We have to subtract 2 here. And then this k we have to do is what? Add the 2. Minus 3. Now let's do this one here. This k minus 2, k plus 2, I'm sorry, square is the same as k plus 2, k plus 2. So this is going to be k squared plus 4k plus 4, right? So this thing is going to give us something like this, summation, that it goes from I equal to 1 to n minus 2 of this one, which is k squared, actually this thing, plus 4k plus 4, and then all of that minus 3, right? So the summation that we actually going to work with now is going to be what n goes, I goes from 1 to n minus 2 is going to be of k squared plus 4k plus 1. Okay, now we can do different summations here, individual, let's say. Let's do that in a second. Okay, now we have here our three summations. One for k squared, one for k, and one for 1. Actually, this is supposed to be a k, not an x. Okay, one for k and one for 1. So now let's apply the formulas that we have here for each of these, except that in this case, instead of substituting a number, we will be substituting n minus 2. So let me do the 1 in a second so you can see how it looks. Okay, and I'm done with the other two, but let's look what I'm doing with this one, with k squared. K squared, the formula is n plus 1, 2n plus 1. So where there's an n, I'm going to substitute n plus 2. So in the first n, this is n plus 2, n minus 2, a minus 2 plus 1, 2 times n minus 2 plus 1. Oop, I forget the right parenthesis here. So, and then we're going to do the same thing for the other two. Let me write it. Now you can see the next one, it will be n times n plus 1 divided by 2, but the n is not n, is n minus 2. And here you're going to put n minus 2 plus 1 divided by 2. But remember, there's a 4 here, so that's why it has the 4. The last term, which is this one, is just this n minus 2 times 1. That's it. Now, I want to, all of them have the same common denominator, which is 6. So this one, instead of putting here, dividing this and getting 2, I'm going to write here 12 divided by 6, which actually is the same as 4 divided by 2, which is 2. And here is going to be 6 divided by 6, so everybody has the same common denominator. I will show you that in a second. Now look what I did. I want all of them to have the same common denominator. So I multiply here by 6 and divide by 6 for the last term. 4 divided by 2 is 2, which is the same as 12 divided by 6, which is 2. And since I want to have in common denominator 6, I put it like this. But remember, this 12 has to be there. Look what I did here. I just, add minus 2 plus 1, we get minus 1. And then the same thing here, distribute the 2, and I get to put 2n minus 4 plus 1 is going to give us negative 3. And then I did the same thing here when I add this one, again minus 1. So now what I'm going to do is do the product of these fellows, and I'm going to do it in a second. Now look, all these products here, I did it here individually. This one is here, the last one is here, and now I'm going to substitute back in the equation. And look what I did. I put back in the equation each of these representing, well, the first one k squared and k and constant. And after regrouping of the numbers, I gave this one n to n cubed plus 3n squared minus 17 plus 6 is equal to the original equation. Okay, guys, I hope this helped a little bit. Try to work with this one and see if I get it right. Bye.